So if we look at the graphing tool for question 5, we have y equals 6 times e to the negative x. So again, our parent function would actually be just y equals e to the x. So we have some transformations to deal with here. So if I click on the graph, again, our exponential tool would be this one. So how to highlight the exponential tool. So what we want to do is it wants us to plot the curve. So this time we actually have to create a table on this one. So we did have this point 0, 1. So we got that going on again. But notice how there's a 6 on the outside. So that's actually going to stretch the graph vertically. So that's actually going to be a coefficient this time. So it changes to a 6. So all it's going to do is make the graph become steeper. Again, there's not a horizontal stretch. That's still going to be a 1. There wasn't a vertical shift or a horizontal shift because there's no adding or subtracting involved with numbers. But notice how there was a negative on the inside. That means it's going to reflect over the y-axis. That's a left and right concept. So the graph should take on this look here. Notice how the base is e. So that kind of would be our tools here to do that. So if I look at our graph, we have f of x equals this 4 times e to the negative x. If I was going to graph this, notice how we have our graphing tool here. When we do so, we should end up also, let me pause a second here and get the rest of that. So we should have a graph now that appears across here. That's going to be our exponential function. But notice how our coefficient this time was a 4. That's going to be on the outside. So this should actually be changed to a 4 here. And then there wasn't a horizontal compression because there's nothing on the inside. There wasn't any shifts. That stays at 0. That stays at 0. But there was a reflection over the y-axis, so that needs to be checked. When you do so, the graph should still be at 0, 1. That piece there did not change. The asymptote would still be here. But instead of the graph opening and approaching to the left, it's now going to be up and approaching to the right. Let me do that in green again. It should be coming down and doing this. So that would be our graph. So it really should stay at the same spot. It should just look a little bit steeper. So if I graph like y equals then, and again, the e is right above the division symbol, or also got this e to the x over here. I'm going to just use this one over here. So second e to the x. But what you actually have to do is put the x there. So if I graph that, that should be my parent function. So I go y equals, and if I come in and do 4 to the, oops, sorry, back up. And just start that all over again. 4, and then I need an e, so second e. I need a negative x there. I hit graph. Notice that the graph does mirror what we did here. So what happens is, actually the y-intercept does change by a factor of 4, so I didn't do that correctly. So there was a vertical stretch there, so instead of being at 0, 1, it should be 0, 4, since we had that going on there. So if I put 0 in, notice that 0 goes in, that's going to be 4 times e to the negative 0, but negative 0 is just 0. E to the 0 is 1. 4 times 1 should be 4. So that actually, this should be not at 0, 1, but I should be at 0, 4. So the vertical stretch does happen there. And notice that the graph is a little bit steeper as well. But notice how it also comes down and still approaches the x-axis. So my graph is not that big of a difference, but I should have 0, 4 as a y-intercept. So if I go to the table on the red one, when x is 0, oops, when x is 0, my y value should be 4. Notice how it did have a stretch 4 times bigger from there. So it's not really a shift, it's more of a stretch from that. That happened from this factor of 4, not the vertical shift here. So that's what my graph should look like. So the domain of this function, again, is going to be no domain restriction. This is still going to be negative infinity to infinity. Notice that the range, again, is, notice how the x-axis was the boundary line. So it's going to be, remember here, the asymptote is actually this y equals 0. That hasn't changed. So if you look at your going to the right, notice how your y values, it just gets closer and closer to 0, and it just gets into these scientific notation numbers there. Okay. So we won't get into all that. So our domain should be 0 as a boundary. We'll go back to green again. But we don't include 0. It's a boundary, and then to infinity. Notice that the horizontal asymptote was y equals 0. Does it ask for an intercept? So the intercept would have been 4 if we asked for that. I don't know if it asked for that one or not. Not just domain, range, and horizontal asymptote this time. But the y-intercept would have been 4. Okay, that kind of completes that one.